that I faced my own mortality was when I was on a 4-person float plane going over the northern wilderness of Canada. And it was frightening because while I was really excited to be able to have this experience and collect these samples, the pilot was quite young, and he made this comment. He's like, I don't think we can land at this lake here. It seems too small. And then one of the other geologists in the group was like, oh, well, I've landed in this lake 6 times in this plane, so it can be done. The question is, can you do it? And in my mind, I'm like, why are you baiting the pilot? But we ended up having a scary but safe landing. And you may be asking, why would I go to such a remote place to find these rocks? These rocks aren't just any rocks, they're banded iron formations, or BIFs. And these are some of the oldest rocks we have on Earth, and they're just as important to you as they are to me as a scientist. If you don't believe me, I'd like you guys to put your hands into your pockets. If you feel any keys, pens, anything with iron, that iron came from banded iron formations, and it's probably older than 2 billion years old. So the big debate about banded iron formations is, how did the iron minerals form? Did they form from biological processes or abiological processes? And in order to answer this question, because we're talking about microscopic life, we're looking for chemical signatures of life. So you get these chemical signatures from microbes because they have different eating habits. So microbes eat elements, but not all elements are the same. Some are heavier, some are lighter. And life tends to be picky and choose the lighter isotope in a process called fractionation. Now, humans fractionate their food as well. So imagine that you have a bag of Chex Mix, and you open it up, and you get that wonderful smell of MSG. And you start to eat the pretzels, you start to eat the rice Chex, but then you come across a bag of rye chip, and you're like, oh, not a bag of rye chip, and you drop it back into the bag. You can imagine that over time, you would have a larger and larger proportion of the bag of rye chips in the Chex Mix bag. So as a geochemist, when I'm looking for life, I'm looking for non-proportional Chex Mix, or isotope ratios for signatures of life. So once we were on the ground and I finally managed to collect my samples, I was really excited. I didn't know what was about to happen, and I was really excited to get the data back. And then the plane came, and I started to walk towards it, and I got the warning to be careful, that it was very slippery where I was going. And so I was being careful, but it didn't matter because I had a backpack full of iron. And I fall and break my tailbone, but the funny thing is that I was laughing at the same time I was crying because it was totally worth it, that I would go back to get those banded iron formations. And I ended up finding that the isotope signatures suggested there was microbial life. So I not only got to experience the joy of discovery, I also figured out how far I'm willing to go for science.
So, yeah, I first want to take issue about the bagel rye chips. Those are the best part. That's a different conversation. So what element and what about it told you that those BIFs were from a microbial precipitation?
So when I did it, it was my senior thesis as an undergraduate, but I actually collected the samples through Carnegie because I was an intern here. So it was Carnegie that made me want to become an astrobiologist. So thanks. But I was looking at carbon isotopes. So that's a more traditional thing. So microbes tend to prefer the carbon with 12 neutrons, not with 13 neutrons, which is heavier. If I was going to do a more thorough investigation, I would have looked at iron isotopes as well, because that's the food that the microbes were eating And that would be where we would be able to find some check mix signatures as well.
And what exactly does this tell you? I mean, why are you doing this?
So the banded iron formations, we don't know if it's formed by biological processes or abiological processes. So if we find an isotope fractionation that suggests that there's life in these rocks that are very old, then it tells us about the early Earth ecosystem. So if we know that there is a type of microbial metabolism going on that is eating iron, we know that that requires a substantial amount of carbon, and that carbon had to come from somewhere, so it'd probably be from phototrophs, or basically like algae that you find in your pond. So you piece things slowly together, the ecosystem that way.
So you said that, oh, by the way, I really liked the check mix isotopic fractionation illustration. That was really cool. It may be true that different people have different fractionation processes, but it was a good illustration. You said something that's surprised me, and maybe it's just my own ignorance, but that if there's any iron in your pocket, it comes from a banded iron formation. Is that, do all iron ores come from banded iron formations?
Banded iron formations are the only iron ores that I'm aware of. Well, so banded iron formations is a term that geologists that study the old Earth use. There's another term for basically the same thing for a different group of geologists that work with younger rocks. So there's a little bit of a name difference there, but it's still rocks that are over a certain amount of iron.
That's really interesting. Thanks.
Thanks.